Hi, this is the second part of the video on algebraic thinking, and we need to talk about the third main idea in algebraic thinking, looking at the structure of the number system. There's a lot of structure underlying the way our number system works, and kids develop a lot of informal ideas about this, and we want to move them towards explicit, more formal ideas, and help draw that structure out from students' own observations and conjectures or guesses at what's always true. Here's an example: the commutative property. Kids are not going to know the name of the commutative property, but they're going to know this idea. If I add 2 plus 7, that's the same as 7 plus 2. Or if I add 3 plus 1, that's the same as 1 plus 3. They're going to understand that idea in an informal way. What's the goal? The goal is to help kids understand that this is going to be true for all numbers. So a plus b is going to equal b plus a, no matter which number a stands for and which number b stands for. We want to stress that this is a really useful thing for them to know, that this is always true. It means that they can always switch those numbers around whenever they need to. We want to draw this out from students' observations, but we want to make it into a formal thing that they recognize as true for all numbers. We don't want to leave them relying on appeals to authority. In other words, my teacher said that's true, so it must be true. Or my textbook said it's true. Instead, we want them to rely on the logic and the reasoning underneath it. We also don't want them to rely on a use of examples. Okay, kids, let's list as many examples we can think of. 10 different examples. Look, it's always true. Instead, what we want to do is we want to come to some kind of logical argument that helps them understand this. And kids, even in elementary school, can do this. For example, they can say, okay, well, if I have a pile of things here, let's not even worry about how many things there are. Let's just say it's a big pile of things. And I'm going to add it to this pile of things over here with some other number of things in it. If adding means I'm going to join these two things together, I'm going to push them all into a big pile. Well, it doesn't matter if this pile's on the left and this one's on the right, or if we switch those two around. When we push them together, they're still going to be the same amount in the big pile. And that's a logical argument that helps us know why the commutative property is true, rather than some kind of appeal to authority or use of examples. So lots of different properties in the number system that we want kids to have those kinds of experiences and think about so they can use them. Another main category in algebraic thinking, a real important one, is patterns and functions. We can start with kids by looking at repeated patterns, and we can do this with symbols, letters, shapes, numbers, all kinds of things. And when these patterns repeat over and over again, it's important to help kids look and think about the core of the pattern. For example, ABAC, ABAC, ABAC. Real quickly, we recognize ABAC as the core of this pattern. This is the part that happens over and over again, and that helps kids realize what's going on in this repeating pattern. The main thing to do with kids here, have them do a lot of explaining of their thinking about how they recognize these. Quickly, we want to move on to growing patterns, where it's not necessarily something repeating over and over again, but instead something growing. An example of this was the number of triangles that we looked up here. Here's a growing pattern in a physical context. We drew a triangle, we drew 4 triangles, we drew lots of triangles. It's growing after every step. We can look at these growing patterns in lots of ways. We can look at the original drawing or the context. We can do verbal descriptions of what's happening. We can create a table that says at each step how many triangles there are. We can make a graph on a XY axis and see how it grows. We can write an equation or a formula connecting those. Important to use all those different representations with kids and help them make connections between them. Why does that equation and that table, why do they both work together? What are the features that connect them? Important for kids to make all the different connections amongst all the different representations. One of the main kinds of growing patterns that kids will study in school are linear functions. It's the main study in an introductory algebra course. It's what happens a lot over and over again in this world. Important for kids to see lots of linear functions where that change between each step is a constant. Last category, mathematical modeling, really brings all of these ideas together. It's the process of taking a real phenomenon and mathematizing it. In other words, paying attention to the mathematical structure of what's happening. And you have to draw in all 4 areas to do that. Important for us to think about how to bring together all those areas and model real scenarios.